All right, guys, so you might want to pause the video and just write these down. To save some time, I did this already. So these are all of our perfect squares. So these are all numbers that you get by squaring a number. And now, since we're in the square root chapter, square roots are just the opposite of that. So for example, let's do a couple of these. If 4 squared is 16, then guess what the square root of 16 is? It just goes backwards, and it's 4. Let's do a couple more. If 8 squared is 64, then if we go backwards, the square root of 64 is 8. And let's do one more. If 15 squared is 225, then going backwards, the square root of 225 is going to equal 15. And feel free to fill all these in if you want. Ideally, you guys want to have these memorized, these perfect squares and their square roots. Okay, but sometimes we're going to see a number that's not on our list. Okay, like square root of 8. If you look, 8 is not one of our perfect squares. So we're going to have to learn how to do this. All right, so if it's not a perfect square, this is what you guys do. So what we're trying to do is simplify these so we can pull out any perfect squares. So step 1, write the prime factorization of each radicand. So we're going to make a factor tree. How could you multiply to 8? Okay, so give me a way to multiply to 8. I'm going to say 4 times 2. And then we're going to keep going down until they're all prime. So now, what's 4 times 4? I'm sorry, what's 4? It's 2 times 2. And now, 2, 2, and 2 are all prime. Okay, so that's step 1. Write the prime factorization of each radicand. Next, circle groups of 2 identical numbers. So do you guys see how we have a group of 2 here? We're going to circle that. This one does not have a group of 2, so we leave it alone. The number from the circled group will show up outside the radical symbol one time. So since you have a double 2, we're going to pull that on the outside, and then anything left over stays on the inside. Okay, so this is the simplified version of square root of 8. So anything left uncircled will remain under the radical. And then this rest doesn't really matter for right now. All right, let's try another one. So 40. Tell me 2 numbers that multiply to 40. And don't pick 40 and 1. I'm going to do 4 times 10, but there's multiple ways to do these. Now keep going. 4 is 2 times 2, and we can stop there. Those are prime. And 10 keeps going into 5 times 2, and we can stop there because those are both prime. Okay, any identical pairs, so I see a double 2, any identical pairs come out once. So if you have a double 2, it comes out once. I don't see any other identical pairs. And then anything that's left over that's not part of an identical pair, you multiply and it stays inside. So this one is 2 root 10. All right, let's do a couple more. Number 3. Give me 2 numbers that multiply to 200. I'm going to do 100 times 2. And then 100 we can keep going into 10 times 10. And then 10 we can keep going into 5 times 2, and then we stop because those are prime. And then this 10 is also 5 times 2, and we can stop because they're both prime. And then this 2 was also prime. Okay, do you guys see any identical pairs? I see a pair of 5s, and I also see a pair of 2s. Okay, so that means we could pull out 1 5 and 1 2. And if we multiply those together, we get 10 on the outside. And the only thing left on the inside is this prime 2. Okay, so an identical 5 comes out, an identical 2 comes out. You multiply them to get 10. And then there's this prime 2 left over. All right, let's try another one. Number 4. 72. First thing that pops in my mind is 8 times 9. And then 8 is really 4 times 2. But then 4 is still 2 times 2. Okay, these are all prime. So we stop. And then 9 can keep going into 3 times 3. And those are prime. Okay, any identical pairs? We have a pair of 2s and a pair of 3s. Okay, so that means a 2 comes out and a 3 comes out. So what's 2 times 3? That comes out as a 6. And then what's the only single prime left over? This 2. All right, if you guys want to stop, go ahead. So if you're feeling good, go ahead and stop here. I'm going to finish it off for anybody who wants 2 more. Okay, 48. 48 is 6 times 8. But then 6 we can keep going into 2 times 3 and stop. And then 8 we can keep going into 4 times 2, but then 4 is still 2 times 2, and now we can stop there. Okay, do you guys see any doubles? Any identical pairs? I see an identical pair of 2s and another pair of 2s. Okay, so 2 times 2 is 4 on the outside. And what's the only prime single left? The 3 on the inside. Okay, and one more if you guys are still with me. Number 6. Now 6, square root of 64, that's a perfect square. Look at our list. 64 is on there. Here we go. 8 squared is 64. So root 64, if you know these by heart, we don't have to do this. It's just 8. So if the number does pop up on our list, we don't have to do all this work. All right, guys, that is called simplifying square roots. And then go ahead and try the practice. Let me know if you need help. Thanks for watching.